Hi, welcome to the 8th Design Patterns and Framework class. Today we are going to discuss the 7th design pattern in this series. So we'll be looking at first behavioral design pattern today, which is the template design pattern. Template method design pattern. So just to recall where are we? Uh, so we have discussed 6 design patterns until up to now. Two of them are creational design patterns, which discuss about design patterns that involve when creating the objects. Then we are discussing structural design pattern that discuss about the structures of these objects. So today we are discussing about the behavioral design pattern, how these objects, how these classes are behaved, and how that can behavior of those the objects can be controlled using a design pattern. So today we'll be using few OOP principles, object-oriented programming principles, inheritance, method overriding, and abstractions. Right. What is template method design pattern? Now, if you look at your environment, there are standard process. You do task A, task B, and task C, which are sequential, should happen one after the other. But depending on the context, how you implement method A, how you implement method B can be different. Example for this is, let's assume you are traveling from one place to another. You're starting from the location A and your destination is location B. You drive to these two locations by two different vehicles, car and a bike. You start, you steer, and then you stop. If you look at in those car, in both in car and the bike, you you start the vehicle, you steer the vehicle, and you stop the vehicle. But you know for a fact that start, steer, and end, or the stop, implementation is different from vehicle to vehicle. There is an algorithm. You have to start, steer, and end, but it is different from object to object. Way of implementing is different to object, with class to class. That is where this template method design pattern can be useful. So template method defines an algorithm. What are the steps that you need to follow? And it's define the, the algorithm, generalize the algorithm for all the given subclasses. Okay. If you look at self-driving vehicles, taking example from the vehicle itself, you want to drive to a destination. You accelerate, steer, and brake. And so you define your algorithm sequence in a superclass, and the implementations are done on the subclass level because the implementations are different from class to class. Okay, so this is again, I'm taking this example from the Coursera course. So let's look at you are making a pasta dish. You in both, whether it might be two different types of pasta, spaghetti meatballs or penny alfredo, and in both cases your steps are same. You boil the water, you cooked it, drain, add pasta, add sauce, add protein. So likewise your steps are same. But depending on the pasta, some implementations might be different. Now, in this case, in some implementation might be different, some implementations are same. Now, if you look at this particular class diagram, you will see boil water, cook pasta, drain and plate are same for both of these different types of pasta. Add pasta, add sauce, add protein, add garnish are different from one implementation is different from one pasta to the other. So what we are doing here is we maintain the sequence, and some implementations are common, which will be implemented in the superclass, and the customized implementations will be done on the subclass level with the same signature. So if you look at this, you have the add pasta method, which will be overwrite at the subclass levels. Right, let's see the implementations. So I have a pasta dish class. If I go back, this is my pasta dish class, which is the superclass, and it's a abstract class. It's an abstract class, not an interface. It's an abstract class. Hope you remember the difference between abstract and an interface. I will just shift it to this next slide, just for you to indicate what are the difference between interfaces and abstract. We have been using interfaces a lot in this module. So today we are using an abstract class. In abstract class, you can have abstract methods and concrete methods. In interfaces, you can have only method signatures. You can have only method signatures, no implementations. But in abstract class, you can have abstract method as well as the concrete methods as well. That's the main difference between interface and abstract class. For your reference, other examples are given in this slide. Right. So now that means this is an abstract class, which means you can have concrete methods as well as you can have abstract methods. So here you have something called make a recipe. And what I'm saying here is, okay, we have a method called make a recipe, and these are the boil water, add pasta. These are the steps for that particular method. And here you will see add pasta, add sauce, add protein, add garnish are abstract methods, whereas the boil water is a concrete method here, which means this method is implemented in the pasta dish class. Now you can see another new keyword here, final. Public final keyword is available. I'm not sure whether we have discussed this before. If you have final keyword, that means when you extend this to a concrete class, when you extend this to another subclass, you can, last week we discussed about inheritance and overriding of those. We can override the method in a superclass, parent class, but if you have the final keyword, you are not allowed to override the method. So that means in a subclass, you can't override the make recipe method. That means even in the subclass, you need to follow these steps. You are governed. So this is a template. That's why it means by template. In this method, this is the order that it should run. First, you have to boil water, then add pasta, cook pasta, drain and plate, add sauce. So you have to go by in these steps. That cannot be different in one class to another. However, in subclass, implementation of add pasta, implementation of add sauce can be different to class. Right. So here you can see two subclasses. Now it is extending from the abstract pasta dish class, and here you are implementing add pasta method in both classes separately. So these are now these are concrete methods in these two different subclasses. You can see all these four are implemented in the subclass level. Right, where can we use this? Multiple classes with same functionality. So you to understand what are the same functionality that you will have. For example, salary calculation. Steps are same. You first calculate the net income, then you calculate the expenses, then you calculate the overtime, no pay. But depending on the employee, these calculations methods can be different. For example, overtime calculation is different from permanent employee to a non-permanent employee. But still you calculate the OT. Calculation method is different. So what we do here is we will do the generalization. If you look at calculation steps are generalize for all subclasses. But how you calculate it different from one class to the other. That's where you inherit and override it. Then this very popular in framework development. As you know, in framework you have steps. You have to do this, that, and the other. So by doing this, you avoid the code duplication. If I go back to the previous code, now you can see in the superclass you are set this method, as well as you have the some methods are concrete methods are there. So when you are inheriting this to a subclass, you don't have to implement the main recipe method as well as few other methods. Those will be so if you look at this one, in the subclasses, you are not implementing make recipe method, boil water method, cook pasta method, drain and plate method. Whereas in this one, again, you do not implement these first four methods. Why? They are concrete classes in the super class. So the code duplication is avoided here. You don't have to duplicate the code in both subclasses. So in this, yeah, and the code reusability. The method that you implement in the superclass can be reused in the subclasses as a virtual method. In this pattern, subclasses can simply redefine the methods based on their needs. For example, so add source. This class will have its own add source method. So you have some customizable methods as well. Right. Let's take another example. This is taken from the book chapter. So I have a main method called basic engineering, and there you have three methods: math, papers, and four methods: math, papers, soft skills, and special paper. So you can see here only special paper is implemented or overwritten in the subclasses. So in the abstract class, basic engineering, only one method is abstract. Special paper is abstract, and all the other methods are concrete methods. Math and soft skill papers are concrete method. But what is the reason behind this? So the simple reason is, for the electronics and computer science, both math and soft skills papers are same, but the special paper is different from electronics to computer science. So since it is tailor-made for the given course, you have to override it at the superclass level. What are the advantage of using template design pattern? Of course, you can control the flow of the algorithms. You can say, do this first, do this second, do this in third step, do this. Likewise, you can control the method. Since it's a final method, derived methods cannot change them. So common operations, you can move it to the superclass, avoid the code duplication, and maintainability will be improved. As I am always saying, there are challenges. Now, what if you have a different sequence of steps for subclasses? You have to deal with the superclass the sequences. Subclass can override method define the parent class. Some methods can be override in the subclass. This if you have large number of subclasses, it can go into a issue. Now if you have more subclasses mean more scattered code, which is difficult to maintain. They are not major challenges, but these are some sort of challenges that you will come across when you are using template design pattern. So I will have some reflective questions here. Now, how does the template method pattern balance reusability and customizability when defining an algorithm structure? In what situation might using the template method lead to rigidity or overgeneralization, and how can this be avoided? Now, as I said before, superclass define the order. It defines the order. There is a rigidity there. So how can you overcome that? And then the last question is, how does the template method design pattern encourage code consistency across subclasses and while it's still allowing super class specific behavior? So come up with examples. I would prefer if you come up with examples with relevant to your projects, and also see how you can implement this template design pattern, template method design pattern in your projects. Thank you. Let's see you and let's discuss more things during the class. Thank you very much.